Hello everybody, hello, how are you all? How are you guys? कैसे हो आप सब लोग? How is everybody? How is everybody today? So I am excited and I hope you guys are also excited for today's session. I welcome you all to this wonderful and amazing series wherein we will be taking care of the science and mathematics portion, the important portion of physics, chemistry and mathematics for half-yearly exams, your upcoming half-yearly exams. So stay tuned, this session is going to be the coolest session and I am sure that you guys will like it. Do reach out to me in the comment box or chat box, have use it very completely and fully and wisely. Having said that, once again I welcome everybody, once again I welcome all my viewers, those who are joining us live and those who will be joining us after this session, which means those who will be looking at this session offline or later the recorded part which will be available on YouTube. So hello guys, welcome. My name is Netrapal Singh and as you all know I am from IIT Kanpur and I am going to teach you today the second part of chapter number 10 from class 10th, that is refraction. So without wasting further time, let us dive into it straight away. Alright, so yesterday we looked at reflection and now today we are going to look at refraction. Hello to all my viewers. Hello, hi Krish, hi Meet, hi Extinct, hi everybody. Do use the chat box and comment box to the fullest. So alright, the first question that comes to mind is, sir, what exactly is refraction of light and why does it happen? What is refraction of light? So refraction of light is simply bending of light. To put it in simple terms, to put it in simple words, it is simply bending of light. Now for us, we have always understood and people all the teachers or the school has taught us that light always travels in a straight line, right? So we have been taught so far that light travels in a straight line, but now suddenly I'm coming to you and I'm telling you light actually bends. When does it happen and why does it happen? So this phenomena first of all is called refraction and this is called bending of light. When does it happen? It happens whenever light passes from one medium to another medium. So if the light is passing from one medium to another medium, then the bending takes place and that phenomena is called refraction. So please make sure that you are comfortable with the definition and you guys stay tuned. Those who have joined just now, it is my humble request, please like our session, share this session in your group, share this session with your friends and get the maximum benefit out of this session. Alright, so like I was saying, refraction of light is bending of light when it travels from one medium to another medium. So let's say on the left hand side you have this image. Let's say this is our medium number 1. This is medium number 1 and this is medium number 2. This is medium number 2. So light is traveling from one medium to another medium. See, you can see that it is traveling straight till this point. Once it is entering medium number 2, once it is at the interface of the medium 2, suddenly its direction changes and it is now in this direction instead of being, instead of going towards this direction, which was earlier thought of. So this is called bending of light. I'm sure you guys can see it very clearly. Also in the second diagram, as you can see, there is this rod. It's a simple rod, it's a wooden rod, and here we have water. This is a glass of water, and on top of that this is oil. On top of that this is oil. So see how remarkably you can see here that the rod appears to be bent at some places. Now this is just an illusion and this is happening because of the phenomena of refraction of light, which means light is actually bending when it is coming to your eyes, when your eyes are perceiving it. I hope everybody is able to see that, everybody is able to look at it. Alright, once again, hi to everybody. Hi. Alright, so this was the second figure, and coming to the third figure, see, have a look at this third figure. So what is happening is this, there is this source of light. So this is called source of light, where the light actually emerges from. So this is the source of light. As you can see, once the beam of light is actually incident on this surface, something interesting is happening. Instead of coming out, earlier it was coming out, but then when you increase the angle or you change the angle, then suddenly light, it appears to be coming in this direction, which means reflection takes place. So I'm going to talk about all these phenomena one by one, and stay tuned, guys. This session is really going to be interesting and informative. Most of all, this is going to help you in your half-yearly exams. All right. Now the second topic comes is, sir, you told us what is refraction, but you did not say anything about why refraction happens. So please write down in your notebook. I'll just write it down here. So the refraction of light takes place because light, any guesses? Light travels in different medium with different speeds. Exactly, with different speeds. So when it travels from one medium to another medium, its speed changes, also its wavelength changes. One thing that remains constant is the frequency. So frequency of a light wave which is actually undergoing refraction, a light wave or a light ray which is undergoing refraction, its frequency remains unchanged, because frequency is the property of the source. It is the property of the source. So I'm sure you guys are well versed with this and you guys understand this point. Now coming to the topic of laws of refraction, the first law is pretty obvious and very, very simple, that the incident ray just like the laws of reflection, the incident ray, the refracted ray and the normal at the point of coincidence. This word is important, coincidence. So at the point of coincidence, all lie in the same plane. This is the first law. So the incident ray, the refracted ray and the normal at the point of coincidence, they all lie in the same plane. I don't think that I have to once again explain this point, because this point was already discussed in the first part. If you guys have not watched the first video, please go through the description box. Also, if go through the playlist and you will find it there. Now coming to the second law, this law is very, very interesting. This law states, this law is actually also called Snell's law. This law is also called Snell's law, and it states that the sine of angle of incidence, the ratio of the sine of angle of incidence and the sine of angle of refraction is given by a constant, and that constant is denoted by mu. Now this mu, this constant, this is called refractive index. You have guessed it correct. So this mu, this is read as mu, mu. This is how you pronounce it. So this is called mu, and it is called refractive index. Yes. Different speed, very good. Difference of speed, wonderful, guys. So wow, you guys are active. You guys are active. All right. So mu is actually refractive index, and this is the second law that you have to remember. Mu is equal to sin I upon sin r in the simplest of terms. All right, now as you can see on my right hand side, there is this figure that I want to show you. This is, let's say, medium number 1, this is your medium number 2, and this is the interface. So once you use the incident light to strike the surface, so this is the incident ray which is striking the surface at point O, and immediately you draw a normal. Normal is any straight line which is perpendicular to the surface. Now we are talking about this normal which is drawn at this point of coincidence. So the angle between normal and the incident ray, this is incident ray, right? We have already seen it in the first part. So incident ray, this is incident ray. The angle between incident ray and the normal is called angle of incidence, I. And what is angle of refraction? this is angle of refraction, this is angle of refraction. Alright, so the light was supposed to go straight if there was no medium 2. If there was no medium 2, the light would have gone straight, but now in this case it is moving in some direction. I'll talk about this direction later on, but for the time being you understand that it is moving in certain direction. Alright, so this angle that you see here, which is between the normal and the refracted ray, this is the refracted ray. So angle between the refracted ray and the normal is actually called the angle of refraction, and that is how Snell's law is applied. So sine of I divided by sine of R is equal to mu. This is Snell's law, and this is also the law number 2. Very nice. Alright, so we have encountered with a very beautiful and an awesome term that's called refractive index. So we were discussing about refractive index in terms of sine I and sine R. Now there is this term called refractive index and absolute refractive index. Let's discuss something about it. So refractive index of any medium, so how it is read is, and how it is written is, sometimes you write it like this, mu21. So you read it as refractive index of second medium with respect to first medium, so mu21, this is read as mu21. Sometimes it is also written as mu21 like this. So this is read as refractive index of second with respect to first medium. Alright, I hope this makes sense. Now refractive index is defined as mu21 is equal to speed of light in first medium divided by speed of light in second medium. So we can write this as, now mu21 is equal to V1 divided by V2. This is very important relation. Mu21 is equal to V1 upon V2. Please write it down in your notebook. Mu21 is equal to V1 upon V2. Alright, now there is one more formula that you need to remember, is that frequency nu is equal to C by lambda, or if you are not talking about the speed of light, then nu is equal to nothing but V by lambda. So using this formula, V is equal to turning out to be lambda times nu, right? Lambda times nu. And so instead of writing V1, we will write lambda times nu, and instead of writing V2, we will write lambda 2 times nu. Now why I have used the same frequency? Because like I said earlier, frequency is dependent upon the source and it is independent of the medium. So frequency only depends upon the source. That is why nu1 is equal to nu2, and I have already used nu as nu1 is equal to nu2 is equal to nu. So both these guys will cancel out each other and you will be left with lambda 1 upon lambda 2. This is also written as mu21. That means these two formulas are very, 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 very important. Please note it down in your notebook. Everybody, please note it down in your notebook, guys. This session is really going to be helpful, and if you follow this session thoroughly, I'm sure you will be absolutely confident in this topic of refraction. Alright, have you written? So I am going to delete it now because I need more space to write some more points. So mu21 is equal to V1 divided by V2, that is also equal to lambda 1 divided by lambda 2. This is what we have done so far. So mu21 is equal to V1 divided by V2, and this is equal to nothing but lambda 1 divided by lambda. Now question arises, sir, what is lambda? What is lambda? Lambda is wavelength. So the length of the wave, or you can say the distance between two crests and two troughs. Let me just quickly draw a wave. So this is how you draw a wave. This is called a crest, this is a crest. So the distance between two successive crests is called lambda. This is the wavelength. Also distance between two consecutive troughs is also lambda. So this is lambda, this is also lambda, this is called wavelength. This is what we have used here, lambda 1 upon lambda 2 and V1 upon V2, because we are going to use two different we are going to use light rays in two different mediums. So mu21 is equal to this also. So I am sure you guys are now you guys have now understood refractive index. Can I have a quick yes or no that you have understood refractive index or not? Hi Vatsal, how are you? Such an unexpected surprise. I am really glad that you're here. I'm really glad that you're here. Alright, so also now mu2 1 is, or it can be written as mu2 divided by mu1. Now so we understood what is mu2 1, because you said mu2 1 is nothing but refractive index of second medium with respect to first medium, and now you're using this notation. So where does the second part go? So the second part actually is air or vacuum, which you need not write, guys. I mean that need not be mentioned here. So you can simply write this as mu2a if you want to just mention the second or mention the other medium here. Similarly mu1a. Now this mu2a, mu1a is read as refractive index of second medium with respect to first medium. Refractive index of second medium with respect to first medium, which means refractive index of second medium with respect to air. And in this case, when the second medium or the other medium is air, then this refractive index is called absolute refractive index. This is called absolute refractive index. When you have other medium as air or vacuum, then the refractive index is called absolute refractive index. Absolute refractive index. Very nice, guys. Just give me a thumbs up if you have understood what I have taught you so far. Just a quick revision, because this concept is very important. I'm again and again insisting on this concept. Mu21 is equal to v1 upon v2, which means speed of light in first medium divided by speed of light in second medium. This is what is going to happen. Let's say this is medium number 1 and this is medium number 2. So when light travels from one medium number 1 to, let's say, medium number 2, it might bend in some direction. Now this bending, so initially the light had a speed of v1 in the first medium and v2 in the second medium. When you apply Snell's law here, all you have to do is you have to write down refractive index of second medium with respect to first medium, and that is equal to v1 upon v2. This is what we have learned so far. Alright. Also mu2a, or let's say mu1a, is nothing but absolute refractive index of medium 1, and this is equal to absolute refractive index of medium 2. Refractive index of medium 2. Now moving on to the next topic, this is called relative refractive index. Indirectly, what we wrote earlier was actually relative refractive index, wherein the second medium was not air and it could be any other medium. So mu21, this is called relative refractive index. This is called relative refractive index. It is actually having no units. This quantity has no units. It is also dimensionless, because it is just the same quantity divided by the same quantity. Next, we have some values written here. The refractive index values for air, it is approximately 1. So 1.0003 is taken to be 1. For ice, it is 1.31 approximately. For water, it is 1.33. I think you need to just revise and remember these important values, especially for water, for air, for let's say, where is glass? So glass is here. Yes, this is glass. So for glass, it is 1.5 or 1.52. So these values you need to remember. Also, if you cannot remember these values, don't worry, because these values will be given to you in the exam. These values will be given to you in the exams. Cool. Nice. Thank you so much for the thumbs up, boys. Thank you so much, and everybody. I love you. Those who have not liked the session so far, please like it, because we are moving on to the next session now. Next topic now. The topic is called optical density. Now this optical density topic is different from the normal density. You remember, density was defined as mass divided by volume. So we are not going to talk about this density here. We are going to talk about optical density here, which means we are going to talk about two different kind of medium, rarer medium and denser medium. Now a rarer medium is one in which speed of light is faster. Speed of light is faster. In denser medium, speed of light is slower. So I'll give you one example and you will be able to understand this. Let's say this is glass, and let's say this is air. So if light is traveling in air, what do you think its speed v1 is as compared to, let's say, if it is traveling through glass and its speed is v2? So let me know in the chat box. I'll give you the answer after a while. Just let me know in the comment box or chat box whether v1 is greater than v2, or do you think v1 is less than v2? Quickly write it down in the chat box so that I get to know that everybody is alive and everybody who is watching this session is interacting with me on a per second basis. Quickly guys, just write down the answer. If you think v1 is greater than v2, then write it down in the chat box. If you think v1 is less than v2, also mention it. v1 is greater than v2 or v1 is less than v2. Let me know in the chat box. Quickly, I'm waiting for your answer, and then only we will proceed. Tell me whether v1 is greater than v2. What do you think? Or it is less than v2. Shabash. v1 is, somebody said v1 is greater than v2. Extinct said v1 is greater than v2. Very nice. Rest first. Very nice. Wonderful guys. So big congratulations to you. Your answer is correct, that v1 is greater than v2 because speed of light in air is more as compared to speed of light in glass. That means air is a rarer medium, like I said, and glass is a denser medium. So I have told you what is a rarer medium, in which the speed of light is more, and denser medium in which the speed of light is less. Now quickly just let me know in the chat box and comment box, which amongst the following do you think is a denser medium? Glass or water? Glass or water? Answer this question also. Glass or water, boys? Glass or water? Come on quickly, we have less time and we have so much to do. I want everybody to secure at least 90% marks in their upcoming half-yearly syllabus. Glass, absolutely, yes, glass. So glass is optically denser medium. It is a denser medium, and water is a rarer medium. If you compare, let's say, oil and water, which one will be denser or rarer? Oil and water, which one out of these two will be a rarer medium and a denser medium? Tell me, which one do you think will be a rarer medium or a denser medium out of oil and water? Now this is a tricky one, huh? Please make sure you think and answer. Think before you answer. That's right. Think before you answer. Now you have to say which one is denser. You have to write denser is this and rarer is this. Denser is this and rarer is this. Oil is what? Tell me, denser or rarer? Water is rarer and oil is denser. All right. Extinct says that water is rarer and oil is denser. Other people, what are you guys saying? Come on guys, let's interact with each other. It's very, very difficult to interact on YouTube. Already, we are lagging in terms of streaming. I don't know what is happening. Yeah. Okay. So we have a couple of correct answers and a couple of incorrect answers. Oil, my dear friends, this is a denser medium. Please don't get confused between the density of oil and water. That was a different density. This is optical density. So this is an optically denser medium as compared to water, because water is optically rarer medium. Yes, those who have answered it correctly, please give yourself a thumbs up and a big congratulations to you guys. Big congratulations. Optically rarer medium is water and optically denser medium is oil. All right, so please don't do this, commit this kind of mistake in exams. Please make sure that you understand this. Now I have a couple of questions, guys. Which way will it bend? Will it bend means which way the light ray will bend. So let's say this is an interface, this is a rarer medium here, and below that we have a denser medium. Now this is the incident light that is incident on the surface. This is the incident light. This is the normal as already seen and written there. Now if there was no second medium or the denser medium was absent, this light would have gone straight in this direction. It would have gone straight, right? If there was no medium, because there is no way that the light can bend now. So if there was no denser medium, the light would have gone straight. But now, since it is moving from rarer medium to denser medium, or before that, please write down, if light travels from rarer medium to denser medium, it bends towards the normal. It bends towards the normal, and vice versa. Vice versa means the just opposite of it. Vice versa. So now coming back to this question, light is traveling from rarer medium to denser medium. All right, so in the absence of the denser medium, it would have gone straight, but now since there is the presence of denser medium, light is traveling from rarer to denser medium, it will bend towards the normal. So now it has bent towards the normal, and this is the new refracted ray. This is the actual refracted ray. This is called refracted ray. All right, and this angle is called angle of refraction R. Angle of refraction R. Very nice, very nice. Next, give me the answer to the next question immediately and quickly. What do you think will happen if you have denser medium here and you have rarer medium here? Just have a look at this. This is your incident ray once again. Incident ray. Now light is traveling from denser medium to rarer medium, and what will happen? Instead of going straight, it will bend away from the normal. It will move away from the normal, and in this case the angle of refraction will be denoted here. Angle of refraction will be denoted here. So are you guys able to see the diagram? Are you guys able to see the diagram? Okay. Yes. Away from the normal. Very nice, very nice. Oh wow, super cool, super. You guys already smart, huh? You guys are very smart. Which will it bend? All right, now moving on to the next topic. The next topic is rectangular glass slab. Now what is happening is, let's say we consider this rectangular glass slab A, B, C, D. Let's say this is a ray PQ which is incident on the surface. This is your incident ray, and once you reach this point, you have to immediately draw a normal. Let's say this is air and this is a glass slab. This is a glass slab. So in the absence of a glass slab, the incident light would have gone straight as shown by the dashed line, right? Now immediately at point Q, just stop and draw a normal like I have done here. So let's name this normal as NN dash. This is the normal. Obviously this angle will be equal to, guys, what will this angle be equal to? Angle of incidence. This is I. Also, now since it is moving from rarer medium to denser medium, it should bend towards the normal, and this is what will happen to the light. So instead of going straight, this is now bending towards the normal, and this angle that you see here is called angle of refraction R in this case. Now let's denote it by R1 for simplicity. R1 for simplicity. Next step is you have to quickly name this point PQ. Let's name this point as R. This point is R, let's say. Now again draw a normal at this point like I have drawn here. So let's name this normal as mm dash, and as you can see, guys, this normal mm dash and normal nn dash, both of them are parallel to each other. Therefore if this angle is R1, this angle will also be equal to R1. This angle will also be equal to R1. Alright, now after striking this surface, you have to think what is going to happen with the light. So for this surface, for the surface BC, this ray QR is actually the incident ray. Now this becomes your incident ray. Abhi ye incident ray ho jayega. This will be your incident ray. Now after refraction, it should have gone straight, right? I mean, if there was no change in the medium. so it would have gone straight. But now since it is moving from denser medium to rarer medium, it should bend away from the normal, and obviously the light will bend away from the normal. This is the direction of the bending of light, and this particular perpendicular distance, this is called lateral displacement. This is called lateral displacement. This is lateral displacement. So please let me know in the chat box, guys. Please let me know in the chat box whether you have understood the refraction phenomena through a rectangular glass slab. Rectangular glass slab. One by one we have looked at it. Just let me know in the comment box or chat box if you have understood the diagram that we have discussed here. Understood? Yes or a no? Immediately and quickly let me know. Quickly guys. Just let me know whether you have understood this rectangular glass slab refraction or not. Krish says yes. Okay, alright. So moving ahead, guys, this is lateral displacement that I have shown to you. This is denoted by X sometimes. This is the perpendicular distance between the initial incident ray and the emergent ray. This final ray which is emerging from the rectangular glass slab is called emergent ray. This is your emergent ray. Alright. Next, examples of refraction of light. Where do you see refraction? Number one, an object that is placed under water appears to be raised. This we have seen in terms of, swimming pool. Whenever you go to a swimming pool, you see that the pool is not that much deep. If you look at it from a certain angle, you see you are able to see, and you are in an illusion that the sea the bed of the swimming pool is actually raised, and the swimming pool is shallow, but it is not so. Yeah. Next, let's take another example. When a thick glass slab is printed over some printed matter, so this glass slab can also be called as paperweight. So when you put a paperweight, especially a rectangular paperweight, the letters just below the paperweight, they appear to be raised when viewed from the top. जब आप उसको ऊपर से देखोगे तो वो जो letters हैं, those letters appear to be raised. That is what is happening because of the refraction of light. Next is a pool of water. It also appears to be less deep than it actually is. Yes, that I have already discussed. A lemon, this one is wonderful. A lemon, limbu pani, a lemon kept in water in a glass tumbler appears to be bigger than its actual size, and this is because of the phenomena of refraction of light. So let's say if you have a lemon which is placed inside this glass and it is filled with water, immediately you will follow that this lemon is actually appearing to be of bigger size. So this is happening because of the refraction of light. Last but not the least is the refraction of light is actually responsible for twinkling of stars. Now we already know that stars do not twinkle, they appear to twinkle, which means they do not actually do something like switching off and switching on. So it is actually the phenomena of refraction of light. These are very beautiful applications. Alright, we have one more application, a stick held obliquely. So this we have seen in the first slide itself. So a stick held obliquely and partly immersed in water appears to be bent at the water surface, that we have seen in the first slide. Let me just go back to the first slide quickly. So this is the first slide, and the second diagram was this. So this is a stick or a rod, and it appears to be bent in at this point of space. Next, moving on. These were the application. Next, now coming to different types of lenses, the application of refraction is actually seen in lenses, spherical lenses. We have spherical lenses, and they are classified as double convex lens, double concave lens. Apart from these two classifications, we have other classifications as well, but this is not the point of talk for class 10th. This is not the point of interest for class 10th. That we are going to study in class 12th. Just give me a second, guys. Just hold on. Give me a second. Yeah. Let me just have water quickly. We are just about to complete the refraction phenomena. Let's have a look at what a double convex lens looks like and what a double concave lens looks like. A convex lens is also known as converging lens, double convex lens, or you can simply say it is a convex lens. Instead of using the word double more number of times, you can simply say it is a convex lens, and it is also called a converging lens. The reason being, see, when the light rays which are incident on a lens such as this, which has two bulged portions, then after refraction, they will pass through a common point, and as you can see, these light rays initially they were going parallel and now they are appearing to meet or at a certain point, or they are actually meeting at a certain point, so they are converging towards a common point, and that is why these lenses are also called converging lenses. Secondly, coming to concave lenses, this is the shape of a concave lens. This is a concave lens. So once a light ray which is parallel to the principal axis, we'll be discussing about principal axis and all these definitions once again quickly. So once a light ray which is parallel to the principal axis, if it strikes the refracting surface, so this is the direction in which it will bend. In which it will bend. Once you extrapolate these two rays, you will see that they will appear to meet at a certain point. And now you can see that these rays they are actually appearing to be diverging, right? So this is diverging in certain direction, and that is why these lenses are called diverging lenses. Now once again guys, terms related to spherical mirrors, let me just quickly go through what is an optical center. So let's say we draw a convex lens. This is a convex lens. Please pardon my drawing now. This is a convex lens. Now let's name this as L1 and L2. This is a convex lens. We have named it as L1 and L2, and this point that you see right here, exactly at the center of the lens, this is called optical center. This is the optical center. Now in the mirror case, this point was called as pole. In terms of lenses, this point is called optical center. Once again, aperture is same, which means this diameter between L1 and L2 point. Center of curvature, we have two centers of curvature. This particular surface can be extrapolated like this, and we will have a center of curvature C1 here, let's say, and this particular surface also can be extrapolated here like a sphere, and this point will be called as C2. You can also interchange, it depends on you whether you want to use this value as C1 and this value as C2, or whichever way you choose. So this is called center of curvature. Principal axis is any straight line which is passing through the center of curvature and the optical center. O, you can call this as O. Coming to principal focus, previous diagram, this is principal focus guys. This is principal focus. So any light ray which is parallel to the principal axis, then after refraction it will pass through the focus, or it will appear to the focus. This point is called focus. So principal focus, first principal focus and second principal focus means this can be called as, this point somewhere down here. So this point can be called as focus F1. This is called principal focus, and this can be called as second principal focus F2. In our case, in class 10th, we are going to look at cases where F1 should be equal to F2. Now focal length, this is the distance between the optical center and the focus. This is the focal length. This is what focal length stands for. Once again, you have first focal length and second focal length. Quickly, rules for tracing images. Next topic, rules for tracing images. The rules remain same. Once a light ray is parallel to the principal axis, after refraction it will pass through the focus. Like you can see in this diagram, this is a convex lens. Light is parallel to the parallel to the principal axis, and after refraction it is passing through this point called focus. And this is the case of a concave lens on my right hand side. Second rule states that a ray of light which is passing through the optical center, it will deflect undeviated. As you can see, if light ray is passing through this optical center, it is not deflecting in any direction, whether it is a convex lens or whether it is a concave lens. Next rule is that any light ray which is passing through the focus, it will obviously be parallel to the principal axis. See, have a look at this. So it is passing through the focus, and after refraction it is parallel to the principal axis, right? Similarly here also, so the light rays are coming in this direction, but after refraction they are moving parallel to the principal axis, and if you extrapolate this, it will appear to pass through the focus, as you can see on my right hand side diagram. Quickly going to do the image formation by convex lens. This is a very important topic. You guys should be able to draw the ray diagrams. When the object is at infinity, which means the object is very far away. When the object is at infinity, you take the rays of light from these 2 points, strike it on this convex lens. After refraction, it will pass through the focus and the image will be formed here. This is where the image will be formed. Quickly, the observation tells us number one, the image is point sized, right? This is point sized image. Secondly, it is formed at the focus, and yes, you have guessed it correctly. Since the light rays are actually meeting, the image is real, and obviously if it is real, it should be inverted. So this is the case when the object is at infinity. Next is when the object is placed beyond 2f or beyond c. So this is 2f, and you have placed this object here. So this is your object height, AB height. This is your height AB, or you can simply use h. We are going to invoke the first rule, which means light ray which is parallel to the principal axis, after refraction will pass through the focus. It is passing through the focus, and light ray which is passing through the optical center remains undeviated. You can see these 2 points, these 2 rays are meeting at a certain point, and this is where the image is going to be formed. Once again, observation tells us that number one, the image is, what is it? Real and inverted. Please pardon my handwriting because it is very awesome. Real and inverted image. Secondly, as you can see, it is smaller than the object. And third thing that you see is that it is between f and 2f, between f and 2f. Next diagram, when the object is placed at 2f, this is the ray diagram. Invoke these 2 rules, simple rules. Observation is number one, same size of the image. As you can see, the image is of same size. So this is the object and this is the image on the right hand side. Both the diagrams state, both these candles state that the size is same. Secondly, the image is real and inverted. As you can see, it is real and inverted. And thirdly, it is formed at 2f itself. If the object is at 2f, the image will also be at 2f. Now just have a look at these 3-4 diagrams. When the object was far away, the image was smaller. When the object came closer to the lens, the image started to increase in size, and here you can see it is the same size. Here you can see it is of bigger size. All these things remain the same. Only difference in the observation will be that the image is larger than the object, and in case of the object being at focus, then the image will be formed at infinity. And last but not the least, this is a very important case, guys. It is one of its own. Alright, so this is probably the only case where the image is formed on the same side of the object. Now this is really very difficult to imagine and a very important concept to remember. Anyway, so this is the object, and as you can see, if you invoke this rule of optical center and the rule of passing through the focus, then extrapolating these 2 points will give you the position of the image. And observation is all the things remaining same, but one thing that changes is that the image is virtual and erect. As you can see in the diagram, it is virtual and erect. Secondly, it is larger than the object. Object से बड़ा है वो, object से बड़ा है. तीसरा, third point is that it is formed on the same side of the object. Quickly have a look at this diagram. Let me know if there is any doubt so far. We are just about to come to an end now, guys. Just the last portion, all that is remaining is the lens formula, the magnification and the power. These three concepts are remaining now. Quickly let me know in the chat box if you have any doubts. Let me know in the chat box, guys, if you have any doubts. Just have a look at this table. Let me know in the chat box if you have any doubt. Those who have not liked our session or those who have not subscribed to the channel, please do it now. This really helps me out and helps the team to stay motivated and provide you with such content free of cost, guys. Free of cost. So it takes a lot of hard work, and we really believe that if you can just show us the support, we'll be able to continue with it with more and more enthusiasm. Let me know in the chat box if you have any doubt, and we can proceed further. All right, now I can see there are no doubts. Thank you so much. So this is a homework for you. This you can already have a look at it in the NCERT textbook. This is just the extrapolation of concave lens. This is the summary of it. Distinguishing. So the question, let's say somebody asked us, how do you distinguish between two lenses, whether it is a concave lens or a convex lens, without touching the lens? The simplest thing to do is keep the lenses close to the page of a book and look for image of the writing on the page through the lens. If the letters of the book appear enlarged, then the lens is convex. That means the convex lens is actually acting like a magnifying glass, right? And if the letters appear diminished, then the lens is concave. This is a very simple test to distinguish between two lenses without even touching the lenses. All right, sign convention, as you all know, guys, we have discussed this in part 1. The sign convention still remains the same. There is no change at all. Please. The only thing that is going to be modified is that instead of using pole, we are going to use optical center as the center of reference. So all distances are now measured from the optical center. O. So all distances are to be measured from the optical center O, and rest everything remains same. That is, if you are moving in the direction of incident light and you're measuring the distance, then the distance is going to be positive, and if you are moving against the direction, then the distance is going to be negative. That is what is the rule. That's what the rules are. Cool. Nice. Let's move on to a certain assumptions that we have used while deriving lens formula. So lens formula is 1 upon f is equal to 1 upon v minus 1 upon u. So there is a slight change between mirror formula and lens formula. In mirror formula, you had 1 upon v plus 1 upon u. In lens formula, you have this minor change called 1 upon v minus 1 upon u. Now assumptions are that the lens is very thin. The lens has a very small aperture. The lens is not that big, and the object lies close to the principal axis. And finally, the incident rays make small angles with the lens surface or the principal axis. Linear magnification by lens. These things also remains the same. Only thing that changes is m is equal to now v by u instead of minus v by u. Please make one change here. M is equal to v by u instead of minus v by u, as was the case with mirrors. So mirrors के case में ये था. This was the case for mirrors, and this is the case for lenses. Rest everything remains the same. So go back to the previous video, go back to the first part of reflection, and you will be thrilled and excited and just in awe how wonderfully we have discussed magnification there. Magnification. All right, let's move on to the last topic of today's session. After that, we have a couple of questions for you guys. Power of a lens, this is simply denoted as P is equal to 1 by F, where make sure you understand and make sure you write it down somewhere, where F is in meters. It should be in meters. If it is given in centimeters, convert it in meters and then do the reciprocal and you will get power. P is equal to 1 divided by F. Very, very simple. If we have, let's say, this lens, again P is equal to 1 by F, same formula. Even if it is a concave lens, then again the formula is going to be same. If you have a combination of lenses, let's say 2, 3, 4, 5, 6 lenses, they are attached together, they are placed in contact with each other, then the final power P. So let's say this is a lens which is having power P1, P2 power for this lens, P3 power for this lens, P4 power for this lens. Total power P is equal to P1 plus P2 plus P3 plus P4. The power adds up. The power adds up. The unit, SI unit of power is diopter, D-I-O-P-T-R-E, and its symbol is capital D. This is how you denote diopter or power. Make sense, everybody? This is the last topic for today. P is equal to P1 plus P2 plus P3 plus P4. Next is some board exam questions. Try these questions. Let's see what is given and how do you go about solving these questions of lenses. It's a very, very, very easy question. This was asked in 2013, a 2 centimeter tall object. So H is equal to 2 centimeter. Everything else remaining the same, guys. The concept remains the same as we have studied in the first part or in the first video. So H is equal to 2 centimeter. It is placed perpendicular to the principal axis of a convex lens of focal length 10 centimeter. So F is equal to 10 centimeter. So now since it is a convex lens, you are going to take the focal length as plus 10 centimeter. Alright, also the distance of the object from the lens is 15 centimeter. That means U is equal to minus 15 centimeter. It is, see, this is a convex lens. The object is placed here. It is, the incident light is moving in this direction. Optical center is here. You have to measure the distance in this direction. Obviously that there is a conflict of direction of the distance. That is why we are going to use minus 15 centimeter. What is asked? Find the position nature. Same question, guys, like we did in the case of mirror. So all you have to do is use this formula. 1 upon F is equal to 1 upon V minus 1 upon U. Therefore 1 upon V is equal to 1 upon F plus 1 upon U. This is turning out to be 1 upon 10 minus 1 upon 15. So this is 5 minus, 15 minus 10 divided by 15 into 10. That is equal to 5 divided by 150. Right? So 5 ones are 5, 3s are 0. So 1 by 30 is your answer. That means 1 upon V is equal to 1 by 30, and therefore V is equal to 30 centimeter. V is equal to 30 centimeter. V is equal to 30 centimeter. This is the speed that you have to, achieve. Now coming to the nature and size of the image, very easy. Magnification is equal to V divided by U. V was 30, U was equal to, how much was U? It was minus 15, right? So this is turning out to be minus 2, and since magnification, first observation, it is negative, the image is going to be real and inverted. Also, if you take the mod of it, minus 2 mod is 2, and this value is greater than 1, therefore the image is enlarged. So this is what you're going to do, what you're going to write. This is how you're going to attempt a question. This question is for you for homework. Just attempt this question in your homework and write the answer in the chat box. Same, attempt these questions in your homework. So that's it from my guys. That's it from my side, guys. Thank you so much for joining. These are some board questions. I really loved it. I really loved talking to you, interacting with you. Thank you so much for joining. It was really, really, really nice interacting with you and connecting with you. I'm sure you guys are going to connect with us tomorrow, wherein we are going to look at a very, very important chapter from mathematics. Yes, we are going to look at Introduction to Trigonometry tomorrow. So we'll see you tomorrow, guys. just let me know in the chat box the feedback that you guys want to leave here. Just quickly give me or send a quick feedback. Can we have a quick feedback, please? Can we have a quick feedback, please? If you have any doubt, just connect with me. I am writing my mobile number here. So 900-5942-333. So ping me anytime. If you have any doubt, just connect with me. I also do career counseling. I am your friend, host, mentor, your teacher. 9005942333. That's me, your Netrapal sir. Signing off now. Thank you so much, guys. Hasta la vista. Good night. Take care. Bye-bye. Thank you so much, guys. You are a lovely audience. Thank you so much. Thank you, Vyom, Marmik, Krish, Extent, everybody. Thank you so much. Thank you for joining.